Chapter 21 review. We're only doing 4 problems, 1, 2, 4, and 11. So the first one is on page 391. A survey organization draws a simple random sample of 1,000 registered voters in a certain town. In the sample, 32% approve of the mayor. The organization estimates that 32% of all 50,000 registered voters in the town approve of the mayor, because that's the best we can do, right? We are going to create a confidence of what's in the box using our draws. How to figure the SE. The organization realizes that the number in the sample who approve out of 1,000 voters, out of 1,000 draws, so estimates, the box percentage, estimates the box percentage. Okay, so I don't really care. I don't know why those little blanks are there. Let's just do the math. So I'm going to stick in 0.321s, and that would leave me with 0.68 zeros. That's the best we can do. So now I find the SD. I take the square root of 0.32 times 0.68. What did that give us? Really? That doesn't sound right to me. Times 0.68. It might be 0.466. Yeah, if they're close to 50%, so in the 45, 44 range, it's always going to be 0.499, but we're quite a ways from that. So 0.466. Okay. Now I need to create the SEP. We're going to do the shortcut divided by the square root of 1,000. So divided by the square root of 1,000. And then we need to turn this number into a percentage. So 1.47%. What does that mean? We expect the average of the box to be 0.32 plus or minus 1.47. Okay? We want to create a 95% confidence interval. Oh, wait, no, we don't. That's all we do. Somebody asked about different confidence levels, so let me do it just to show you. If I want, I'm going to say that's 1.5. Close enough, right? 1.5. That'll just make it easier. So if I want a 95% confidence interval, that's plus or minus 2 SEPs. So 2 SEPs would be 3. So my answer is 32 plus or minus 3. So that would be 29 to 35. Everybody understands that? What if I don't want a 95% confidence interval? What if I want a 75% confidence interval? So instead of 2 SEPs, I need some number that's smaller than 2, right? So I go over to my z-score chart, and I find 75%, which is 1.15. And so instead of 2 SEPs, I do plus or minus 1.15 SEPs. So I would do 75 plus 1.15 times 1.5. That will give me the upper end of 76. Or no, wait, it's not 75, is it? It's 32. That gives me an upper end of 33.72. And then I just go in and change that to a minus, and that will give me the lower end, 30.27. Now, what do you notice about these two confidence intervals? The second one is not as wide. How come? I am less confident, right? When I lower my confidence, then the window shortens. How else can you shorten the window? You get more draws. So if you had your choice, if you ended up with a confidence interval and you didn't like it because it was too big, is it better to lower your confidence level or take more draws? More draws. Okay, did that help, Darian? All right. Then I erased it. Number 2. The Residential Energy Consumption Survey found in 2001 that 47% of American households had internet access. A market survey organization repeated this study in a certain town with 25,000 households using a simple random sample of 500 households. 230 of the sample households had internet access. A. The percentage of households in the town with internet access is estimated at. Are we looking at 2 different surveys? Okay, so we're probably doing the market survey. Okay, so 239 out of 500. It is 47? 47.8. So in the box, we would have 0.4781s and 0.522 zeros. Okay, this estimate is likely to be off by, well, what's the SD going to be? 0.499. So let's just call it 5. So my SD is 5. I need to turn that into an SEP. So I do 5 divided by the square root of the draws, 500. 5 divided by the square root of 500. And then turn that into a decimal. Oh, sorry, 0.5. I did that yesterday. So it's 2.2%. So 47.8 plus or minus 2.2. Okay. If possible, find a 95% confidence interval for the percentage of all 200 or 25,000 households with internet access. If this is not possible, explain why not. Okay. Can we create a 95% confidence interval for that city? Yes, all the draws came from the city. Can we say, so originally, that first sentence says all American households. Will our confidence interval hold for all American households? No. Does one city represent the whole country? No. So we can create a confidence interval for the city, but we cannot for the country. So we're just going to double this. 4.4, 47.8 minus 4.4, and then 47.8 plus 4.4. That's your 95% confidence interval. Excuse you for softball. And then, what was it, 4? Number 4? Okay, among the sample households, 121 had no car, 172 had 1 car, and 207 had 2 or more. Estimate the percentage of households in the town with 1 or more cars. Attach a standard error to this estimate. If this is possible, explain why not. This is not possible. So we're going to add the 172 and the 207 together. So we'll take 172 and we'll add that to 207. And we get 379 out of 500. So 75.8. And then the standard error, we're going to take the square root of 0.758, and we're going to multiply that by 1 minus 0.758. You guys understand that? Oop, I put divide. That won't work. Does that make sense? That is my SD. To get an SEP, divide by the square root of 500, 1.9%. We good? Yeah? All right. Number 9, hypothetical. A bank wants to estimate the amount of change people carry. They take a simple random sample of 100 people. Oh, 11? Okay, never mind. Number 11. 100 draws will be made at random without replacement from a large box of number tickets. There are 2 options. To win $1 if the sum of the draws is bigger than 710. Win $1 if the average of the draws is bigger than 7.1. Which is better, or are they the same? So let's look at our 2 boxes. So 1, you win if the sum is greater than 710. Okay, and how many draws are we making? 100 draws. Okay. In the second box, we're also going to take 100 draws, and you win if the average is greater than 7.1. What's the difference between the sum and the average? How do we turn the sum into the average? Divide it by the draws. We take the average. So we divide it by 100, and 710 divided by 100 is 7.1. Okay. So they're the same. Now, what if you do 101 draws? Then the sum would be better. Because if I do more draws, is this number going to change? If I do more draws, will my sum get larger? Yes. So I guess what I meant is this number. Will this number change? Nope. The sum will get bigger, but the number of draws gets bigger too, so the average will remain the same. So, for instance, you're going to do 1,000,000 draws. Would you rather win if you have more than 710 or more than average of 7.1? What's the chance if you do 1,000,000 draws of getting more than 710? 100%. Unless there are zeros in the box, but okay. That does it. That's it.